Hello everyone, Adesoji is my name. You're welcome to this virtual classroom of the course titled Methods of Chemical Analysis with the course code CHM 303. It's a 2-unit course comprising of 10 study sessions, which I mean by 10 topics. It gives insight into areas, data treatment, sampling, and various means by which samples can be analyzed in a chemical laboratory. It would also give you insight into what is expected in CHM 408, which is your analytical chemistry. Let's move swiftly to the first study sessions, which is the theory of errors. The overview of this is we'll be talking about definition of terms, types of errors, systematic errors, types, effects, and detection. We'll also be talking about random errors, accuracy and its measurement, precision and its measurement. Now, let's talk about learning objectives. By the end of this study session, you are expected to be able to define the terminologies in theory of errors, to also be able to describe the types of errors inherent in chemical analysis, then also calculate errors numerically by quantifying them. You are also expected to be able to describe the precision and accuracy of an experimental setup. Now let's go to our definition of terms. Errors. Errors are inherent mistakes, they are blunders, they are inherent mistakes that arise from either a source that can or cannot be determined. Precision is the degree of closeness of a replicate set of measured entities. And accuracy is the degree of closeness of a measured value, just one value, to the true value. Then someone will ask me, what is the true value? A true value is the expected, or what we call the acceptable value. It is usually a tested standard. Now, we have two basic types of errors. We have the determinate errors and we have the indeterminate errors. Determinate errors are called the systematic errors, while the indeterminate errors are called the random errors. And determinate, from the word, as the word implies, they are errors occurring from a source that can be detected, measured, or corrected. The indeterminate are those errors occurring from sources that cannot be detected. Let's take a look at this chart talking about errors. Errors are mistakes caused by someone or something at a particular point in time that has affected the normality of the expected result. Now, we have two basic types, like I said the other time, the systematic error and the random error. We can see some of the examples here for both the systematic errors and the random errors. Then we have the different types of systematic errors, which are instrumental errors, method errors, and the personal errors. These are also some of the examples there. We would be dealing with them very well in the course of the study session. Now, let's take a look at the instrumental errors. Instrumental errors are errors caused by the equipment or electronic devices used for the analysis. It could be due to unreliable value from a measuring device. For instance, this inlet is this picture is talking about the adsorption machine. It could be as a result of tear and wear of any part of this instrument. It can cause an instrumental error. When there is a tear and wear of your ultraviolet visible spectrophotometer, it can cause that. Or your oven, if you are meant to set it at 40 and you are seeing you are actually the thermometer is reading 100 degrees Celsius is actually an error. Then your muffle furnace or your measuring cylinder or your volumetric flask, your weighing balance, if it's not properly calibrated, it can also cause instrumental errors. Discoloration of your cuvette. For instance, this experiment is using your methylene blue dye, and in your cuvette you are meant to use your UV visible spectrophotometer too. If it's discolored, it will add to your analyte, to what you are expecting. So that will be a source of error. That's for instrumental error. The good news is that we can fix them by proper periodic calibration of equipment that you're using. This will eliminate the types of errors. Now let's look at the method errors. These are due to misappropriation of the methodology used for one's analysis, such that the ideal physical or chemical behavior does not take place. They are often difficult to detect. Method errors are usually due to the incompleteness and speed of the reaction. And these are some of the examples, the side reactions, and they might also be very difficult to detect. For instance, when you are doing your titration, then the good news is that we can fix them we can fix all these thematic errors, including method errors. Now, one, we can fix them by accessibility to a known amount of analyte, that is your standard, by standard organizations, which would help us fix the errors. Now, the second way is by using our related journals, that is our successful experimental write-ups that have been done by authors, established authors, and that be consulted by researchers. This also might be of help when we look at their methods they have used and we apply it to our own. We will say that we get a good result. Now, personal errors are also types of systematic errors. These errors are caused by the analyst, that is the person analyzing the chemical analysis. Okay, that is the person in charge of the analysis, and these occur where measurements require judgment, and it might also result from bias, from color problems, among so many others. Some examples are here. For instance, when someone is colorblind, the person might engage in personal error rather. And an apology to our men folks, most men are said to be colorblind because so many of them call purple pink, some call hash black, and some even call hash white as they deem fit. So we can fix these errors by awareness, by adequate care, and by self-discipline. So we can also have in the laboratory there's what we know as color wheels. So we can it's an embodiment of color, so we can see different color parts. So if you are not too sure of a color, you can go to the color wheel and look at the results you have and juxtapose with the color wheel. Then this shows different colors. We can also use white tiles for quick detection of our color change, especially during titration. White tiles will make you to see everything embedded. Now let's take a look at some of the effects of systematic errors. We have one, the constant effect, the constant and the proportional. Constant, it says that the deviation becomes more serious as sample size becomes smaller. That is, the absolute error is not dependent of the magnitude of the measured quantity, that is the size of the sample. Here we would see that the percentage relative error increases as a volume decreases. But for proportional error, which is another effect, the absolute error increases as the size of the quantity measured decreases. I hope you're getting me. Then here in proportional effect, the percentage relative error is constant with the volume, and this can be in terms of volume, weight, as the case may be. Let's go to our detection of systematic errors. We can detect them, like I told you, it can be detected and can be corrected. Now we have like 5 listed ways here that we have listed in which we can detect them. One, we have the standard reference materials, and these are materials containing one or more analytes of known concentrations, which can be synthesized or purchased from governmental agencies or industries, like National Institute of Standards and Technology, NIST. Then the standards are samples of known composition. We have a standard reference materials. They will be of best estimate and bias of the analytical methods. Then we also have a second way of detecting this, which is a blank determination. And these are done in such a way that all steps of the analysis are employed on the blank, that is the solvent alone. The sample is matrix and analyte. The blank is matrix alone. All reagents, components, and steps except the analyte. So that is what we have for blank determinations. So all other things in sample is embedded. All other things, the reagents, the components, the steps. But in blank, all other things are not except the all other things are there. So except the analytes. But in sample, all other things are there, including the analytes. Now we have another one which we call the independent analysis, and this is done by employing another method that is a reliable analytical method and a second independent method along with the method being evaluated. For instance, a method A by group 1 students, we have a result A. Now the method B by group 2 students, we can have a result B. Now we can compare result A and result B together. So when we compare these two results, we can see that, oh, okay, this result, we are getting it or we are not getting it. So it depends. You can assign your group 1 students to be 10 or group 2 students to be 20 as the case may be, but you just compare result A from the group 1 students and compare it to the result B from the group 2 students. Now the fourth method is by assigning different analyses using same samples. So You use identical samples, or it could be same or different method. Please take note. This is just for you to check out for the mismatched results. Now the fifth way here is I'm talking about the variation in sample size, and this can be used to determine the constant errors such that the size of the measured sample increases, and while the effect of the constant error decreases. Now let's take a look at the random errors. Now, like I told you the other time, random errors are indeterminate errors. Now there's some other things that they cannot be corrected, they are inherent, they're natural, they are not preventable, and they are usually called constant errors. Let's take a look at this precision and accuracy, which is the measure of these errors. Now, precision talks about the reliability and the consistency, while accuracy talks about the validity. Now, let's look at this diagram. This image, the first part talking about A, that is high accuracy and high precision, that is consistently doing well. Imagine you throw an arrow 5 times to a targeted small circular object on a wall, and you are consistently right. That is high accuracy and high precision. But when you have the B part, is talking about high accuracy and low precision. It's accurate, but the precision is very low. The C is talking about low accuracy and low precision. When you are not right, you are not even consistent at all. That is low accuracy, low precision. But when you are consistently wrong, so to say, low accuracy and high precision, that is G. So we can see that from that diagram. Now let's talk about accuracy. We've been talking about accuracy all along. So what is accuracy? Accuracy is the closeness of the measurement to its true value, or what we call the accepted value, and is usually expressed by an error. We can have the measurement in terms of absolute error or relative error. The absolute error is just the difference in the true value, the difference of the true value from the observed value, while the relative error is the absolute error divided by the true value multiplied by 100%, as the equation can be seen from here. So take a look at the example. It's also embedded in your module too for proper understanding. Now let's talk about precision. Precision is the closeness among measurements of a set obtained exactly the same way. Now, precision, it also talks about the repeatability and the reproducibility of measurement, and it can also be measured in terms of variance, standard deviation, absolute error of the mean, range, and coefficient of variance, which some people refer to as the percentage relative standard deviation. That is percent relative standard deviation. So all these, I expect you to have known them in your secondary school days, but you can just take a look at this and these equations, and also in your module is properly embedded there with some examples. Now, basically, we have been able to achieve our learning objectives by defining our terminologies, describing the types of errors, calculating our errors numerically, and by being able to describe our precision and accuracy. Okay, now I expect you to have been able to identify the errors, the sources, with respect to the basic types and calculation relating to them as explained in this study. Now, can I just give you some self-assessment questions? Please, I want you to attempt these following questions. Define these terms in just a sentence: random errors, systematic errors, true value, precision, and accuracy. And I want you to list 10 types of errors that can occur in a laboratory experiment of your choice. Assign them appropriately to the source of error you identify. Then I want you to explain in your language these terminologies: precision and accuracy, determinate and indeterminate error, absolute and relative error. Then I have this take-home assignment for you. All these assignments and self-assessment questions can also be seen in your module, so just take a closer look at it, and you can still check your module for answers. And on this note, I really want to say thank you for listening.